A little bit. The theoretical side of derivatives today.
Why do the theory?
Because you don't understand the concepts of calculus. Actually, hold it, let me stop this a sec. Here we go. Limits. You can't always do limits from a graph. So, if I said, for example, but normally when you're presented with a limit problem, it'll be like this one up here in the top left. X approaches 2, and they'll give you the actual function. So the question is, if they actually give you the function, how do you find the limit? Type what in the calculator? X squared. Okay, and graph it? Is that what you're saying?
Yeah.
Okay, do we know what the graph of this one looks like? Thank you. A parabola shifted where? Up one. If we don't know that's a parabola up one, we're in serious trouble. Okay, so yeah, I drew the parabola and I shifted it up one, over one, up two. I went over one, up 4, etc. Okay, this is asking you the limit as it approaches 2. And it's not got a plus or minus behind it, so it's 2 from both sides. Okay, well, since this is one continuous graph, that's not a problem. It's not piecewise. You can approach 2 from both sides. Where's the y-coordinate going? When my x-coordinate comes in here toward 2, my y-coordinate's up at 5. So, yeah, the answer to my limit is 5. Now, tell me how you could have done that without the graph. How could I have gotten 5 with just that starting equation? 2 squared plus 1. If I sub the number in, sub 2 in for x and worked it, wouldn't I have gotten 5? Ta-da, welcome to the first step of working limits. You put the number in and see if it works. If you get a legitimate, valid answer, you're done. Now, if you get an undefined or something weird, then you got other issues. But the first step is most functions, it works to just sub the number in and see what you get. Okay, so you'll notice here, I have step 1, sub the number in.
That's probably on our journal.
I'll bet that's on your journal. Okay, so let's try a couple limits here. I have this one looks horrible, nasty little function. I want to do the limit as x approaches -4. Alright, so what does it say the first step I should do? I should put -4 in. Okay, beware your negatives. What do I get when I put -4 in there? Positive or negative 16? Positive 16 plus 12, because I'm going to take 2 negatives. And then on the bottom, I have square root of -4 plus 8. Which square root of 4 or 2. And so I would have 28 over 2, which is 14. Ta-da, you just worked your first limit problem. You got a legitimate number answer, that's it. This function, when the x-coordinate is going toward -4, the y-coordinate is 14. That's all it takes. Okay. Yeah. So yeah, what happens if you don't get a nice number? So for example here, if I put this second one, if I put 3 in, 9 plus 12 minus 21, the bottom's going to be 9 minus 9. What is that going to result in? That results in 0 over 0. Okay. What exactly is 0 over 0? Okay, 7 over 0 is undefined. 2 over 0 is undefined.
It's not undefined.
This is like we don't know what it is. So the official math name for it. You're close. Indeterminate. You can't determine what this one is yet. You can't tell from this particular look at it. So we're going to have to try some, in our case, some algebra on it, see if we can do something to it to make it not be indeterminate. But when you get 0 over 0, that's considered to be an indeterminate form. When I get to teach full calculus, there's several different indeterminate forms. Infinity divided by infinity is considered indeterminate, because how do you know which infinity is bigger, the one on the top or the one on the bottom? Like saying, we don't know. So there's several different indeterminate forms we work with. 0 over 0 is by far the most common, though. Okay, what we're going to try is we're going to try some algebra on it. Okay, looking at this little fraction, what's probably the most common algebra you could do to that? You could factor it. Yeah, you're going to factor and see if you can cancel. Okay, forgot to threaten you with an inch of your life.
What? What?
Okay.
What the heck?
In calculus, notation is critical. You must write LIM and x approaches the number in front of it. As long as there's a variable in the problem, you have not found the limit, there better be LIM in front of it, or I'm taking off a half a point for every time you don't write it.
And you're putting a hole in her brain, apparently.
So, you better be writing limited. It's not that hard. Well, once you get a number, then you stop writing it because you've got an answer. Yes, you do. It has to be limited as x approaches whatever number it's approaching. Alright. That, you cannot shortcut notation. It's critical to know what you're doing. Alright, so the top one, actually, I shouldn't have assumed that they're both going to be binomials, are they? The top one's a trinomial. What's it going to be? I'm looking for the actual factors here, dudes. Factors of 21. 7 and 3 with a, thank you, plus 7, minus 3. Okay, you haven't gone totally brain dead yet.
Wow, that's nice. Thank you for complimenting.
Well, you're pretty zoned out, looking out there like zombie land.
That's a good show.
The bottom one I could take out an x. The x minus 3's cancel out. That's your goal. If you get it to factor and cancel, then can you put the number in and get a value now? If I put 3 in for x, 3 plus 7 would be 10 over just x is left is 3. Is that a valid, legitimate number? 10/3 is great. We love it. Answer. So you hope that factoring and canceling will do the trick for you.
And what if it doesn't?
Well, I don't have time to tell you all that this year. We're going to do one other version. Okay, this one up in the top right corner, though, this is more a need for me to make sure you remember algebra. Yeah, I'll tell you right now, if you stick -5 in this one, you're going to get 0 over 0. My question is, how do you factor the top? Perfect cube.
X plus 5 times x squared minus 5x all over 25.
It's the perfect cube rule. The binomial, remember it's 2 terms times 3 terms? The binomial, what do you have when you uncube those?
You have two things, x plus 25.
X and 5. The sign stays the same. Okay, so you got x plus 5. Okay, if you get to the trinomial, you use what you wrote in the binomial, and you square the first thing you wrote. So it's x squared. You change the sign. If this was plus, you go minus. And yes, and you multiply the two things you wrote in the first binomial. 5x. And then you square the last number. Positive 25. Ta-da! You factored it. You should know that by now. You should know that one. Okay, now, the bottom one you learned in Algebra 1. How do you factor perfect squares? Thank you, Colin. X plus 5 and x minus 5. And golly gee, look. The x plus 5 cancel. It's magic. Actually, that trinomial will never break farther. Yeah, that one, when you do the factor perfect cubes, that trinomial will never go farther. If you can't get the numbers to work out right on the sign. I'm sure it's been proven. So now, all you need to do is sub the numbers in to get the final value. So if I put -5 in for all these x's, that's going to be a positive 25. If I put -5 in the second term, that's going to be positive 25 and plus 25 over -5 minus 5, -10, yeah. That 5 is, so I would have over -10. So if you add that all up, that's 75 over -10, which would reduce it can be 15 halves, or it can be 7.5, yeah. You can go decimal if it's exact. I can, if it's exact, don't round. If it's exact, I could live with it. I don't want decimals unless it divides exactly. Don't, if it reduces to 2/3, don't tell me 0.67, because that's not accurate, that's got error.
So if it basically has a termination,
If it's a terminating decimal, you can use it. Yes. There you go. Alright. Whoa, dude, didn't want that. Alright, this is me
I'm gonna
again.
have to draw those graphs. I think I should.
You don't have to draw the graphs, I draw the graphs, you just have to look at them.
This is not gonna be that bad, then.
No, this is not that bad, it really isn't. Alright. This is more, do you remember back to the good old days of algebra? We did some of this. We saw a little of this first semester, not a lot. Alright, same problem, it's a limit problem, what do? Sub in 64, which will give me 8 minus 8 over 64 minus 64, which is 0 over 0. Uh-oh, indeterminate. Okay, now here's where it goes crazy. Cody, how do you back to that? Tim, get rid of that phone. Out of your hand, under the desk, out of sight, not where you can reach it. Put it away. If I catch it again, it's mine.
Eventual sacrifice to her mascot.
Alright, so, if I'm looking at this, I can't factor something that doesn't even have exponents on it. So yeah, if you read my notes over there, it said, oh, try conjugate. But who remembers what a conjugate is? Let me take you back to the good old days again. When we were working with roots, and we didn't like that square root in the denominator, yeah, we multiplied by 2 minus the square root of 5. That's what we did. Because, why did that work? What did that do? Yeah, it does it. Conjugates do amazing things. If you multiply those two conjugates together, what happens to the outers and inners? They always cancel. So all you have to do when you use a conjugate is first and last. So 2 times 2 is 4, and square root of 5 times itself is 5. So you end up with 4 minus 5, you're rid of all the roots. Okay, we can use that same idea. But in this case, when we're doing limits, we don't care whether the roots are on the top or the bottom. We're wanting to clear the roots out. So which one should I do the conjugate of? The numerator or the denominator? You still do whatever the root is. Doesn't matter if it's on top or bottom. That's the distinction between what we did with algebra. So in this case, what would be the conjugate I would be multiplying by? Square back to plus 8. Be sure you change the sign in the middle. And then I, of course, have to take that times the bottom, because you've got to multiply it to keep it an equivalent fraction. You've got to do the same thing on top and bottom. It's the top that's going to get interesting. Notice, I'm still writing limit, because I'm still going to have x's in my problem. On the top, what will first get us? X. We know they're conjugates, so you only have to do last. 8 times 8 is, so you're going to have, now, on the bottom, do I FOIL it or leave it as 2 binomials? You want to leave it. You're looking to get something to cancel. That's weird and ugly. If you multiply those together, it is nasty. Leave those alone, because you'll notice if you leave them alone, something cancels. You're rid of those.
And I get.
Okay, now you can sub the number in. Now that I'm putting the number in, I don't write limit anymore. What's left on top? 1. And then you just have to put square root of 64 in the bottom. 8 plus 8 is 16. And ta-da! There is your limit. So if it involves roots, conjugates can be real helpful. But that's about the only time you'll see that. If you don't see roots, you won't think conjugates.
Use a conjugate.
Yeah. You remember. Right.
That's the part I remember.
You're almost.
Because they referred to
Excellent,
something
because
else.
now I'm ready to start talking